Okay, so we are looking at the dilations worksheet. We've got triangle TRY has been dilated by a scale factor of 2 to create the image TRY. Okay, we're going to use the line tool menu, geometry point, and line to make a line that connects R to our image. What part of the axis does the line cross? So let's start with our calculator going along with this. Okay, so you should have logged in and you would get all the files transferred to you. I'm going to hit open. It's going to take a minute. Shh. So it just takes a minute to open always. I don't know why. It's because so many calculators are doing it once, I believe. Okay, so I'm on dilations, yes? Because I logged in, and then it should just say go to or open, because I've sent it to everyone. Yep, dilation, and then it should say 2 next to it or whatever. Okay, so now I'm going to go to menu. So I clicked the menu button. Okay. I am now going to go to geometry, number 8 here. I am then going to go to points and lines. I am then going to go to line. And I'm going to make a line from R to R. So it says it right on your paper. So if we look on your paper right here, it literally tells you in bold how to go from one to the other, how to get there. Okay? So once you've made that, what part of the axis does this line cross? Okay? And then we want to find the length of T to R, which luckily is right here. Okay. T to R is right up there. Right here. Okay. And how, compared to the length of image TR, how are these different? Does the area is over here, of the image TRY and the area of TR along the same left-hand side, be as specific as you can, how do they compare? So is one bigger than the other by how much? Okay. So if we're looking, I'm literally reading off of this. You're going to answer A, B, C. Are the pre-image and image of the triangles isometry, have isometry, or are isometric? Remember what that means? We've done that in the last two of the calculator activities. Isometry means they are the same, right? Like this, these two squares are the same. I just moved one to the right, one's to the left, but they're isometric. They have the same measure, same angles, same area. So you're going to answer that. And how do the coordinates of TRY compare to the coordinates of image TRY and coordinates of pre-image TRY? Once again, you need to be specific. And then you're going to move on to each of these pages and answer these questions. Okay? Please raise your hand if you have a question. This needs to be done today in class. Okay? It's on the calculator. Can't do it at home. So you need to put your phones away. And you need to actually do this. And I can come around and maybe I need to take phones and hold them up here for the hour so that we get that done. We're going to write a rule to describe each transformation for these dilations. So it's kind of figuring out how much it dilated. Okay? And we can do that if we look at n. If n is 1, -1, 2, and my image n is -2. Went over it 1, 2, and it is up. Oh, not 2. It is over 1.5. And then is up 3. What happened to that? Why does it look like that? What rule can we look at and say, oh, that's what's happening? Is there a number we could multiply that by? Times 0.5. So this is the rule. It would be times 0.0 times 0.5. Excuse me. Okay. Now if we look here, we're going to dilate all of these by this number. So we're literally timesing both of them by 0.05 or by 1/4 or whatever. So if I look, I'll just do it with x. X is 1, 2, 3, 4, -1. If we times both of those by the dilation, which is 0.5, my new x would be, instead of 4, it would be 2. And instead of 1, it would be negative. Oops, that's -1. Yep, it'd still be -0.5, right? So my new x would be 1, 2 here. Okay. All right, so that is what you were doing today. I gave you an example from both sides of the homework. And we talked about how to do the calculator activity. We need to do the calculator activity in class. Again, if I see your phone out, I am going to take it and put it up here for the hour because people are not getting their calculator activities done in class. So please make sure you ask questions so we can work on this.